Alright, so today I'm gonna really teach you the simplest thing I find in the complete calculus, and it's just really called the mean value theorem. Now, if you know the basics about what is average rate of change, what is instantaneous rate of change, you know how to calculate them, then you're gonna really easily grip on this mean value theorem thing. Now, for this thing to be true, we need to have a function. Let's say we need to have a function g of x. We're going to take a function g of x. We're going to plot it, and this its plot is just going to look like something like this. Let's say the graph. Let me draw this straighter. All right, this is our y-axis, and this is our x-axis. I know that this is y, and that is this x. All right, now for this function, we need to take an interval. We need to take a closed interval. Let's say we take an interval a and b. All right, and we have a closed interval, and we're going to analyze this function g of x into this closed interval. And let's say we have got a here and we got b here. All right. And in this interval, let's say we got a function. The function simply looks something like this. And let's say it starts here and then it goes there. Right? And let's say the function just simply looks something, let me draw it a little smoother. Let's say that something looks like this. Alright, it can be a much smoother. Alright, now we saw that the function just simply looks like this. This is a function g of x. This is function g of x. Alright, and we are analyzing that function in between the interval a and b. Now, what does the mean value theorem says? Now, the mean value theorem says that it's average rate of change. You know that this is going to be the average rate of change of the graph of this interval between the points A and the points B. All right, this is the average rate of change. I know that this is g of A, and we know that this right here is g of B. All right. And the average rate of change is just going to be the slope of the secant line, and that is going to be g of b minus g of a. All right, and that's change in y. That's g of a over, we got b minus a, and that thing is just equal to change in y over change in x, and that is called the average rate of change of this uh, function between the points a and b. And now what does the mean value theorem says? It says that between these intervals a and b, there has to be at least one point at which the instantaneous rate of change is just going to be equal to the average rate of change. And what does that thing mean? Let me do that in a different color. Alright, now we see that this point right here, we got what was instantaneous rate of change? We know that instantaneous rate of change is the rate of change of the graph at the instant at some point. All right, and that's the just the slope of this tangent line right here. And now we see that approximately, all right, I'm just approximating because I drew this with hand, and now, well, analytically that's just going to be exactly same. So what does the mean value theorem says? It says that between these intervals a and b, between these two intervals a and b, there has to be at least one value or one point where the instantaneous rate of change is just going to be equal to the average rate of change. Alright, now we see that this tangent line has exactly the same slope as this secant line. Alright, and now we're just going to call that value, and that's some point, that is some point C. Alright, and now let's see this mathematically. What would that mean? That would just simply mean that the average rate of change, you know, that this is the average rate of change between A and B, is just simply at some point going to be equal to f prime of x, or the instantaneous rate of change, let's say the f prime of c. Alright, and I find this theorem really simple in the mathematics, in the whole calculus, and it's really easy to understand. We know that, yeah, we got two functions, we got a function, and then we got an interval, a closed interval a and b. Alright, and now one more thing to remember: the function need to be continuous over this interval. Alright, because otherwise this wouldn't be true. Alright, in order for a function to be continuous, the functions should continue without any jumps, without any breaks from one point to another. And we see that this interval, in between this interval, the function is simply continuous. All right. So it's really simple thing. The mean value theorem. It just simply says that between these intervals a and b, for a continuous function g of x, there has to be a simple point. There has to be a single point where the average rate of change is just going to be equal to the instantaneous rate of change. Now we got one point here. There could be 2 points. There could be three. There could be thousand. There could be a million points at which this thing happens.